Welcome students, this is Mr. Gee with a video that will go over the practice tests that I have on Canvas to help you get ready for a retake that you need to do. Some of you did okay on the retake. We still have quite a number of students that need to retake it, and hopefully we'll get your grade up to where you'll be passing or even better before the end of the term. So this video will be in Canvas. It's also on my YouTube site. I'll have a link in Canvas to where you can watch it from there, and it'll be under the assignment midterm practice test. Okay, let's go ahead and get started. We'll begin with doing problems 1, 2, 3, and 4. If you know how to do problems 1, 2, 3, and 4, it'll actually do almost half the test. So pay attention really closely to this. If you have any questions on it, you certainly can come in and get some help. So here we have a binomial. A binomial meaning you have two terms in parentheses. This is a trinomial where we have three terms in parentheses. And the best way to do this is to do the box method. You're going to draw yourself a rectangle, cut it into three pieces, and then along the top or along the left hand side you're going to label these two terms. So you'll put 2r and a -5, and then across the top we'll have 5r squared, then we'll have a positive 4r, and then a -5. Now the idea is each cell should have a value that's based upon the row that it's in and its column that it's in. So this first column, this first cell should be 2 times 5, which is 10, then r to the first times r squared, which would be r to the third. So in the same fashion, I should go 2 times 4, first row, second column, right? So that would be 8. There's an r to the first times r to the first, so that would be r squared. And the last one would be 2 times a -5, which would be a -10. And then the r just comes forward. Then we do the same thing with the second row, first column. So -5 times 5 would be a -25. R squared. -5 times 4 would be a -20 r, and then last of all we have a -5 times a -5, which would give me a positive 25. Now something I thought I made clear, but I think there's still some questions out here. If you look along this diagonal here, this is a like term and that's a like term, so these two need to be added. You just don't leave them separately. Right here, these two need to be added, so a -20 and a -10. So let's look at these two like terms. I have a -25. Let me fix my pen here. -25, and then I have an 8. Well, you can't go 8 minus 25, because 8's not big enough to subtract 25. So this is what we do. We take 25, subtract 8. That gives us 17. And because 25 has bigger digits than 8, we leave that as a negative. So this middle term here is a -17r squared. This term here, if you look here, we've got a -10 and a -20. They both have the same sign. So what we do on this one, we just add them up and we get a -30r. Now let's go ahead and add our leading term, which is 10r to the third. And then the last term is a positive 25. So that is the correct answer that you should have when you take this test on your own. And that's basically a good way to do it. Number 2 is very similar. Let's go ahead and draw ourselves a rectangle. Let's cut it into thirds. I know it's hard to draw straight lines, and I even have a program to do it, and I still can't get it very good. So there we go. So again, we'll put the binomial on the left hand side and the trinomial across the top. Let's do the first row, first column. 8 times 8 is 24. K times k squared would be k to the third. Then 8 times 8 is 64. K times k is k squared. And then 8k times 1 would just be 8k. Now let's do the 2. 2 times 3 is 6, so this would be 6k squared. Do you see how the diagonal is now forming with like terms? 2 times 8 is 16k. And then last of all, 2 times 1 is 2. Now let's do our like terms. 6 plus 64 is 70k squared. 16 plus 8 would be 24k. And then our last term is 2. And our first term is 24k to the third. So that's the correct answer for this one. Alright, let's move on. Now if we look at numbers 3 and 4, they may look different from 1 and 2, but how you do them is pretty much the same way. And this is the thing that you have to remember. A lot of you know that x squared equals x times x, right? Well, this is kind of like x. So you have 2 of these, just like this. You have 2 of these, right? 2 of these that you multiply together. So really this is 8k minus 3, and then 8k minus 3. That's what we've got. So why don't we just use the box method to do this? Instead of having a 2 by 3, we're just going to have a 2 by 2. So we put 8k minus 3. And then we also put 8k minus 3. So this is 64k squared. 8 times 8 is a negative 24k. A negative 3 times 8 is a negative 24k. Get the 24 in there. And then a negative 3 times a negative 3 is 9. So now do you still see the like terms? There's 2 of them. So we have 64k squared. There's 2 of these, so you can kind of go 2 times a negative 24 would be a negative 48. So 48k, and then we have 9 on the end. So that is the right answer for number 4. Now number 3, that's the right answer for number 3. Number 4, you do in the same fashion as the other 3 problems. Let's draw ourselves a rectangle, split it into 4 pieces, and then here we have 8. I'm going to raise this up just a bit. Have 8 and a positive 3x. We have 8 and a positive 3x. And now let's do the columns and the rows. So 8 times 8 is 64. 8 times 3 is 24x. And then 3 times 8 is still 24x. And now 3 times 3 would be 9x squared. So you can see that this doubles to, again, like 48. So now we have negative 8x squared plus 48x plus 64. So you can't make mistakes on any of this. You've got to have them exactly what needs to be. If you miss one of this stuff, I'm going to mark the whole thing wrong. There's no partial credit. So there's problems 1, 2, 3, and 4. And now we're going to go ahead and do problems, let's see, 5, 6, 7, and 8. Okay, now on problem number 5, a lot of you are trying to solve this for R, or like on number 6, solve this for B. You don't solve these. These are an expression. All you have to do is simplify these. There's nothing to solve. So basically, you just simply distribute and you collect like terms. Alright, so for this one, I'm going to take 5 times it to 10R, and then take the 5 times the 9, and then I'll collect like terms. So Number 5 would be 5 times 10, so that would be 50R. And then 5 times 9 would be 45. And then I add the 4. So the answer for this one, now you got to collect like terms here. You just can't leave them like that. So we have 50R, not R squared. There's not an R on the 5, so it's 50R plus 49. That's simple. Okay, just integer math, right? Now on for number 6, it's a negative 9. So the 7b is out here at the front. Negative 9 times 4 would be a negative 36. And a negative 9 times a negative 4 would be a positive 36b. Now these are your like terms here. You've got to add those two together. You're not multiplying them, you're adding them. So 36 plus 7, 6 plus 7 is 13. So this will be 43b subtract 36. So that's your correct answer for number 6. Okay, now these next two are equations that you have to solve, and these aren't that bad. Let's make sure there's no distribution to do here. You just simply collect like terms first, and then you're going to solve using the solving steps. So 8 and a negative 8, that goes to 0. Okay, 8x minus 8x, that goes to 0. So now we have 10 equals, well, 4x and a negative 6. Well, so 4 subtract 6. We can't do that, but we can go 6 minus 4 is 2x, and because 6 is a bigger digit than 4, that's going to be a negative 2x. Now let's go ahead and solve this. We divide a negative 2 to each side, so we end up getting x equals a negative 5. That's the correct answer for number 7. Okay, now on here we've got m minus 2 equals a negative 10 plus 3 m. Let's get our variables over here. So I'm going to get the m's over here, and I'm going to get the numbers over here. So I'm going to subtract 3m. That goes to 0. Subtract 3m. That's a 1. So 3 minus 1 is 2. So 2m. We keep the negative sign. Now we're going to add 2 to each side. That goes to 0. A negative 10 and 2. So 10 minus 2 equals 8. And we keep the negative sign. Now we just simply have to divide by the negative 2. So m equals a positive 4 for that problem. Okay, let's go ahead and do number 9. Now, one thing you've got to remember, this is a radical. We have to change it to an expression, exponential, rational exponents. If there's no exponent there, there's a 2. And that's called the index, and that is the exponent. Now, when you write this, you have the base on the inside, then you have the exponent on top, and then you have the index on the bottom. Okay, so the exponent is 5, so this will be 2x. 5 is on top, and 2 is on the bottom. Now, a lot of people miss this. There is actually an power on this, and it's a power of 1. Most of you wrote this as 5b to the 3/4. You wrote it like that. No, this is, if you want to look at it this way, this is the way this should be written. Let me erase this so that I can show you. Think of it like this. Let me get the right pen out here, sorry. Do you see there's a 1 right there? See how there's a 5 here? If there's no exponent, what is there always? There's a 1. So that's the way that should be. And so now when you have that there, this becomes 5 It's not a very good looking 5. So 5b, the exponent is 1 and the index is 4. So that's the correct answer to number 10. And I don't think I marked it wrong on anybody that had this type of problem. I still gave you credit because that was just kind of a weird thing, and hopefully I look at the test really well and you don't have one of those on the retake. Okay, let's go ahead and do numbers 11 and 12 and then we'll be done. Okay, so 11 and 12 had to do with complex numbers. And what you got to remember about complex numbers, if we're not multiplying, you just treat these things just like a regular variable. So I'm just going to drop the parentheses on this. There's no multiplication on this. So they put the parentheses on here so you could recognize and realize that, hey, we're dealing with imaginary numbers here. That's all those parentheses on this problem do. Okay, that is it. So now let's collect like terms. Well, these three things are alike, aren't they? So that is I. 1i plus 2i is 3i. So now I have 3i and a negative 8i. Well, what will that be? 8. So you have 8 minus 3 would be 5. The 8 is bigger, so that'll be a negative 5i. So it's simple. This is just 8 minus 5i. That's it for the answer. A lot of you are trying to multiply this stuff together. No, it's just addition. Just addition and integer math. That's all that it is. Okay, let's go ahead and do this one. Now this is just like problems 3 and 4. Absolutely, this is a binomial. Okay, it has an imaginary part, you know, where you have an I, which I is the square root of a negative 1. So across the top we'll have 1 plus 2i. Then we have 1 plus 2i. So 1 times 1 is 1. 1 times 2i is 2i. 2i times 1 is 2i. Sorry, 2i times 1. 2i times 1 is 2i. And then we have 2i times 2i. Well, that's 2 times 2 is 4. I times I is I squared. Now remember, I squared equals a negative 1. Right? So right here, let me do this in red, you have, it's not red yet, you have times, still haven't got it in red, times a negative 1. So this thing right in here actually becomes a negative 4. You okay with that? It becomes a negative 4. So I'm going to write this in green. So that is a negative 4. So now let's go ahead and do our answer. So I have 1 minus 4 plus 2i plus 2i, right? So this gives me a negative 3 plus 4i. That's the answer to number 12. So going back to the very beginning, these are how you do these problems, 1, 2, 3, and 4. And they're very similar to the last problem on the test, which is problem number 12. Okay, let's look at the next two, or the next 6. So again, on 5 and 6, you don't solve anything, you just distribute, collect like terms. 7, 8 are the only two solution problems. So make sure you distribute, then you collect like terms. On these two, there was no distribution. Sometimes there is. And then 9 and 10, it was just writing exponential radicals, change them to rational exponents. Remember where the exponent goes on the top, the index goes on the bottom. And if there's no parentheses around this, remember there's a 1. Okay, then last of all, for problem numbers 11 and 12, number 11, you just collect like terms. It's not multiplication, just collect like terms. And then number 12, you got to remember right here there's going to be an I squared, which causes a sign change, and then just collect like terms. So hopefully this video will help you out. Make sure you view it. We'll do a little bit of a spot check before I allow you to take the test. There's no sense of coming in if you haven't studied. You're just wasting your time and wasting mine. So please study before you come in so we can have a good experience when you do your retake and I grade it. Okay, thanks for tuning in and have a great evening.